Alright, so we can get started. Let me make sure the recording is running. Okay. Alright, let's go on to the next slide. So first, we talked a lot about how we can run different methods in Java, right? So we know about non-static methods like this first one. It's called run this, and kind of like a review of loops here. I just wrote like a for loop. So you know this is going to run 5 times from 0, 1, 2, 3, and then until 4. And it's just going to print each of those numbers on a new line. So that's what we're doing in this method. And that's how we are writing a non-static method. So most of the time we'll be making, actually all of the time, we'll be making like a new instance like this. And then we'll be running the method using this new instance. But sometimes we can also run a non-static method in another non-static method like directly. I didn't show it on here, but in this case we're running it in main, which is a static method, so we have to make an instance. So for this next method, which is called like same for all, I made it static, and that's why the name is same for all, because it's the same method for all of the instances of the class. So in that case, we'll call it using the class name like this. We'll say test dot same for all, because test is the name of the class that I gave in this case. So we covered like how to write these methods and how we can actually run them. But there's there's some methods that we didn't cover, especially like recursive ones. We didn't talk about this, but another way that you can run non-static methods was using this. So this is a keyword in Java and in JavaScript, but we're focusing on Java. In Java, you can use this to refer to a certain object. So if we see this example right here, it's still the run this method, and it has the same code, but we're calling another method called run that. And this is what I was talking about before, like how you can call non-static methods without like needing to do this, but this is only if the method that you're calling it in is not static. So for a method to call another method without like making an instance, they would have to be like either both non-static or both static. So here you could also call same for all without needing this test dot part. But yeah, here you can say run that directly and run this because both of them are non-static. And this would be the same thing as saying this dot run that. So this is kind of like what's the word? It's like intended to be here, but it's like not actually there. So yeah, every time you run it like this, there's like an implicit this there. So these two are the same thing technically. And one thing to know about this is that you can't use the this keyword inside static methods because there is no object that can be referred to in static methods, right? Because static methods refer to, or they can only be used for all of the instances of the class. So yeah, that's why we use this in non-static methods like this. Alright, next up we have recursion. So recursion, let's look at an example first. What you can immediately tell is that like the entire method, it's like it consists of this if-else kind of structure, right? So we have this part right here. This is called the base case. Okay, we'll see why it's called the base case, but just know that that's what it's called. And this else right here, this is what the recursive case is. So when we first run this method, we need to give a parameter called n, which is an integer, and then we'll see what n is equal to. If it's 1 or 0, then we return 1. Otherwise, we return whatever this is equal to. And most of the time, you can probably guess that we won't be running the method with either 1 or 0 as the value of n, because there's like a lot of numbers, right? So the base case only really occurs for a few values. However, the recursive case, this is going to be what you're going to be dealing with most of the time. So for the recursive case, it's going to call the same method over again, and it's going to check again, like, have you reached the base case? Otherwise, let's go on and do the recursive case again. And each time we run the recursive case, something should change. Otherwise, it's going to be like an infinite loop, right? Like, we don't want to call factorial n without this -1 here, right? Because otherwise, this may evolve into like a infinite loop. Because we'll go here, we have a certain value of n, and then this is not going to run, and then we run this, factorial n times factorial n, so that is going to call factorial n again with that same value of n, and it's going to go to the else, and then we see that like it's an infinite loop. So we want to change something with the parameters when we're doing a recursive method. So you can see that with many recursive cases, we will eventually like drop down to like some kind of base case here, and I'm just like highlighting it with my cursor, but there's nothing here. I'm just like showing like a structure. So we'll have like a recursive case here, and then at some point we'll go down to like the base case. So that's the base of what our program will return. That's when the recursion stops essentially, and then it goes back up to the top of the stack, and then it will actually find out what the value of the function was. So let's see what that actually means, because that might not be very clear. So when we're tracing this program, we'll actually like draw like a stack kind of structure, like blocks stacked on top of each other, and that shows like the different kinds of recursion that we go through. So let's see what we're doing here. In the main method, which is going to run first, we're calling system.out.println, right? And then we have factorial is being called with a parameter of 4. So let's go to my auto draw, and then let's do factorial. Let me write that again. Factorial 4. So I'm just gonna call it f. So this is going to be at the top of our stack, and then let's see what else happens. So when we call factorial as a function with a parameter of 4, it's going to first go here, and it's going to see, is 4 equal to 1, or is 4 equal to 0? No, clearly not, so it's not going to run this. So then it's going to call this, return n times factorial n minus 1. So n has a value of 4, right? So we'll say 4 times, and then factorial of 3, because 4 minus 1 is 3. And then you can draw an arrow to show that we go from this case to this case. So we have like this 4 times on the outside, and we have like a f of 3, or like factorial with the parameter of 3 on this inside of the block. So these blocks, what they show is your function call, and then whatever's outside is what we'll have to evaluate after the recursion is done. So we'll see how that exactly works. But for now, let's see how factorial with an argument of 3 would run. Is 3 equal to 1 or 0? No, so we're going to go down here, and we're going to return 3 times factorial 2, right? So 3 times factorial 2, and that's going to be our function call. So from this case, we're going to go down to here, and now we have factorial of 2. So n is 2 at this point. Is 2 1 or 0? No. So we return 2 times factorial n minus 1. 2 times 1. Because 2 minus 1 is 1. So now we have f of 1, and now n is 1, right? So is 1 equal to 1? Yes, it is. So we return 1. So what does that return mean? Well, we can just say 1 like here, and then we return it to this. So the value of this is going to be equal to 1, right? Because that's what the return statement exactly like means. This expression is going to have a value of 1. So now we have 2 times 1 basically, right? Because we said this value right here was 1. So 2 times 1 is 2. So all of this is going to be the value of f of 2. So f of 2 is 2. And then 3 times 2 is 6. So all of this is going to be the value of f of 3, which is 6. and then 4 times 6 is 24. All of this is going to be the value of f of 4, which is 24 now. So we can say this is equal to 24, and that's our final answer. So if you didn't know, factorial is actually like a math function, factorial, and if you multiply this, or if you do a factorial function, it's going to, what it's going to do is it's going to do something like this. So we have this formula right here. So if we have a number called n, and we say n factorial, which is represented by this exclamation mark. Wait, let me do this. Then what we do is we call n times n minus 1 times n minus 2 times n minus 3. So what this is doing is like it's going to multiply all the numbers that are less than whatever n is. So if we have 4, then it's 4 times 3 times 2 times 1, and then it goes all the way down to 1. So if you had like 1 factorial, that would be 1, and 0 factorial, this is defined to be 1. So that's a definition. So yeah, that's a quick overview of factorial. So if we look right here, we have 4 factorial, which is 4 times 3 times 2 times 1, which is 24. And that's exactly what we are doing here, right? We do 1, 2 times 1, and then 3 times that, and then 4 times that. So it's basically 4 times 3 times 2 times 1. And that's what we are representing with the recursive function. So recursion is like, what you can see here is that we're repeating some kind of task. So it's like a loop, which is why tracing recursion is like pretty important, and that will help you like understand your programs better if you decide to use recursion. So let me know if you have any questions about that, like if it wasn't clear, you can put it in the chat. But yeah, we'll see like how, we'll see more examples of this and how it actually like works. So here's a summary. What is recursion? Calling a certain method within itself, right? Because we were calling the factorial method within factorial, so that's like defined within the code. That might be kind of like trippy or kind of strange to some of you, but you'll understand like how it works, because it's not very complicated. It's actually like pretty elegant in some ways, because it's a lot faster, or not faster, but a lot like simpler than some other methods that require us to use loops. Because if you see here, I wrote any recursion program can be written using loops, and if we write this function using loops, it looks a lot more like complicated than if we did it using recursion. So yeah, recursion is a way for us to do problems elegantly and kind of like in a simplistic manner. And then I put one more note here: recursion is not always needed and may not be the best idea in all cases. So yeah, that's also true. Even though recursion can sometimes be better than loops, it's not always the best, and sometimes loops are actually better. So you need to know like when do you use recursion, when do you use loops, that kind of thing. And that's something that you kind of know with practice, which is what we'll be doing. So here I wrote like the factorial function, but I used a loop, and you can already see like I used a lot more space than I did for the previous one. 1, 2, 3, 4, 5, 6, 7 lines, but for this one it only took 4. So here as well, we also had to use like more variables. We had to make a new variable called num loops, and this would use more memory. So not only is the recursive program more like simple in this way, but it's like more memory efficient, which is something that you probably want to deal with when you're making like larger programs. Anyways, the main idea here is that like you can write recursive functions with loops, but it's good to know like when you should use recursion and when you should use loops. So yeah, we can like review this pretty quickly. So we have a loop function right here, right? Same thing as before, we have a parameter n, and then our result is going to be 1. We set it to 1, and then we set number of loops to n. Why do we do this? Well, we'll see right now. So we make an iterator called I, an iterating variable, and then we set this to equal to 0, and then we'll repeat it num loops amount of times. So basically n amount of times, right? when we're doing factorial, it's like we're multiplying. If I go back, if we multiply, if we do factorial 4, we're multiplying a number 4 times, right? We're doing 4 multiplications. So that's why it's going to be less than number of loops, or n. So if this was 4, we would loop 4 times, and then we would see result times equals n. So we're going to multiply result by n and then set that equal to result, and then we're going to decrement n by 1. So this is why we made a num loops variable, because if we use n here, then n would decrement, and that would kind of mess stuff up. And then we would return the result after this looping is done. So each time we're decreasing n by 1, as we did in this factorial. So n is this number, and then we set that equal to result. So result would be 12, then it would be 24, and then it would be 24 after this, and then that's our result. So yeah, that's the loop version of this, and you can see it's more complicated, so that's why we use factorial. Now let's see, what do we need for recursion? Well, we talked about this, like, we need a base case, right? This is going to be our initial case that will stop a recursion, and then we need a recursive case. This will be executed during recursion. So you can have multiple base cases, you can have multiple recursive cases as well, but it's important that you have one of each. Sometimes you'll have recursive functions that only have like a recursive case, and I mean, I guess it could work, but if you want to have like good coding practices in your program, then it's good to like clearly show that you have both of these in your program. So yeah, you can see here, usually the base case is highlighted by returning like a constant like 1, or a character like s, or like a string, like a defined value basically. Whereas the recursive case, it's usually defined with like variables like this, and you have a call to the method that we're recursing. I don't know if that's a word, like recursing over, but the method that we're calling basically. So yeah, that's what the recursive case consists of. So I put an analogy here. If this is kind of like confusing, you can think of it kind of like juggling, or rather peeling an onion. I mean, juggling isn't also an analogy, but I changed it later, so this title is actually wrong. But anyways, so it's like peeling an onion. You remove one layer at a time, revealing another layer underneath, and then you keep peeling until you reach the core of the onion, which is like the base case, right? And then at that point you can stop peeling because you can see the entire onion in its simplest form. Whereas, like, I put a juggling analogy because, like, with juggling, imagine you're juggling like an apple, and each time you like catch it, you take a bite out of it, and then you juggle it again, and then you take a bite out of it again. So you keep on repeating that process until you get to like some base case, which is like when there's no more apple left, right? Because you've eaten all of it. So at that point, you can stop the juggling, and that's like the end of the recursion. So recursion is like calling a method over and over again until you get to like a simple base case, or simple form of the method where like the variable is like too simple, I guess. Alright, so I coded the onion peeling example. It might seem kind of like weird, but this will help us like actually like understand how that works. So you can see I have the base case here, right? That's when there's no more onion left. So layers left equals 0. Layers left is my main variable for my like recursive peel function. So I print finished peeling, and then otherwise we'll print peeled onion. Now we're at a certain amount of layers left, and then we call the peel method again, except this time we decrement the number of layers left by 1. So let's try tracing this program, because this might be kind of interesting. So wait, let me see. Alright, so we start with our main method, right? We make a new instance of the class and then we call the appeal method because this is non-static, right? So we have to call it using an instance in a static method. So our layers left is initially 10, so we have 10 layers left. So is 10 equal to 0? No, so then we go here. Then we print now at 10 layers. So we can say 10 just for now. And I should write that we're calling the method with 10 as a parameter. So that's our main function call. And then this is going to be like our output. So yeah, let's go on to the next part, next case. So now we call it with 9. Is 9 equal to 0? No. So then we go a bit down here. So we have p of 9. Then we go to 8, p of 8. It's going to go here to the top. Is 8 equal to 0? No. So we don't do this, we do this. So p of 8. And I think you guys can see a pattern here already, right? So this is going to go all the way down until we get to 0. So I'll just do like dot dot dot. And then at this point we have p of 0. So from p of 1 we call p of 0. And once we get to p of 0, we print out finish peeling. So in our output that's going to look something like you have 9, 8, 7, and then we go all the way to 1. And at 0, we say finished peeling. So FP for short. So at that point, we're done with recursion. And since we're not returning anything here, it's just going to stop terminating. And it's going to get rid of all of these in memory. So we don't have to worry about like going back up. We only have to worry about going down because we're not returning anything. So yeah, that's the case for just printing something to the terminal. Whereas, okay, so if we go back here, we can see that we have an return type, and we're returning some value. So we have to actually like handle this calculation. That's why we're going back up the stack and like evaluating all of those cases. So let's go back. So we finished this. We saw how we can evaluate like a recursive function without like returning a value, and we saw like how this connected to like a real life scenario, right? Like an onion peeling scenario. Let me actually just change the title. The juggling analogy is still correct, but since I put the onion peeling thing, I'll just keep it as that. So let's try tracing some examples in case if it's not clear. So in this case, I have a, let me clear this out first. So I have a try this method, right? We have 2 parameters this time, and we're changing 2 things. So I can already see that it might get a little more complicated. So let's see what we're first doing. So we call the main method, and we call try this. Notice how we're using the class name here because both of these are static methods. And then let's look at our parameters next. So we have A as 60 and then we have B as 0. So first thing we do, we print to the terminal. We have A 60 and then B 0. So I can just say output like here, and then we have 60 and then 0. So this is going to be A and this is going to be B. That's kind of small, but yeah, just know that A is before B. So 60 and then 0. If A equals B, then return 1. Well, 60 is not 0. It's not equal to 0, so we don't return anything. Otherwise, let's call the same method, except we call it with A minus 10 and B plus 2. So we're going to say 60 minus 10, that's 50. So, oh, I didn't even write the function calls. So that's like really important. You should write those. So I'm going to have try this. I'll just call it try t, and then 60 and then 0. So that's our main function call. And then we're going to have 50 and then 2. That's our second call. At that point, we print 50 and 2, so we see 50 and then 2. And then we go back to here, because this is not going to run, obviously. So we call 40 and then 4. So I'll just say 40 and then 4 like this. T of 40 and 4. And then we go back here, and then we see that we're printing 40 and 4. 44. And then let's call 30 and 6. So then we print 30 and 6 because that's the first thing we do. And then are these two equal to each other? No, so we go over here. Then we do 20 and 8. And then we print them out, right? So 28. And these two are not equal, so we do 10 and 10. And now this is where our recursion will stop. But let's see what happens when we get to 10, 10. Is it going to print? Well, alright, so when we call this method with 10 and 10, it's going to go up here. Then it's going to print it. So we need to print 10, 10 into our output. And at this point, it's going to see A is equal to B because both are 10, and it's going to return 1. So this is going to return 1, but we're not doing anything with that 1, right? So you may be tempted to say like 1 right here, but notice how we're not printing anything to the terminal in the main method. We're only printing in this method. So that might throw you off. It's kind of like a trick. So watch out for like what you're actually printing. Sometimes you may be printing in the method, sometimes you may be printing in the base case or the recursive case, and sometimes you may be printing only the output of the method. So even if you see a print method, it may be only printing one thing in the end, and that is the result of this recursion method. So if we didn't have this print right here, and we only called a print method here, and we printed the expression try this with parameters 60 and 0, then we would print 1. So none of this would be here, but we would only print 1. But because that is not there, because we have this print method right here, we are printing all of this. So that is why we see all of this output in the terminal, and that is actually how you would trace this program. So yeah, that is this example. So we saw how to pay attention for what you're printing, and then how we can actually like call the recursive and base case again. So it's like more practice basically. And one thing I actually didn't do here, you see these \n, right? So these are called escape sequences. These are like special characters that you can put within your code, and this will allow us to like put special like characters in the terminal. So in this case, the output is going to look something like this. So you see here, let me make this bigger. So we're going to print new lines. That's what the \n means. Every time we have this oops, I guess I messed something up. So you see here we have like these \n's. That's where it's gonna go to the new line and then print the new line. So you see here we have A, we print the value of A, then we go to the next line, then we print B, and then we go to a new line. That's gonna be right here, and then print ln is going to print one more new line, so it's going to be right here. So yeah, that's why we put the \n's. I didn't put it here because like there's not enough space to write all of that, so yeah, that's why. Let's clear this now and let's see what our next example is, because I put quite a few examples actually, just for us to get like a lot of practice with this. So we saw this example, let's see this one. So now we have to try that method. We still have one parameter, or we now have one parameter instead of two. And we have only one if statement here, so there's no clear base case and recursive case just by looking at this, but you can kind of infer that if a is greater than or equal to 55, then this is not going to run. So that's kind of like our base case. And notice how also here we're not returning anything, and notice where we're actually printing something. We're printing something in the recursive function. We're not printing anything in the main method. So let's see how this is going to work. We first call try that with a parameter 40, so let's go back. So try that. I'll just call it t and then 40. That's our first call. What happens when we go up here? Is 40 greater than, or is 40 less than 55? Yes, it is. So we say we want to add 5 to that. So it's going to be 45. And then we call that with a. So we can say t of 45. And notice how this print statement is actually after the function. So we're not actually going to get to this until we go to our base case, right? Because as soon as we get here, we call the next function, or the next function. We go to the next function call, and then we come down here, we go to the next function call. So it's not going to get there until this if statement evaluates to false. At that point, we actually say that this is false, so it's going to go down here, and then we'll see what happens after that. So yeah, let's see what happens when this statement evaluates to false, or when the condition evaluates to false. So we go all the way to 55. So you can see here 45 is 45 less than 55. Yes, it is. So we say 45, t of 45, and then that's going to call t of 50. So t of 50, and then t of 50 is going to go here, and then it's going to be like, is 50 less than 55? Yes, it is. So we call it a becomes 55, then we call it t of 55. So we can say t of 55. Then let's see what happens. So we get to 55, right? A is 55. 55 is less than 55. No, it's not. So that's going to be false. Now we say we want to print 55 plus a comma. So our output, it's going to look like 55 and then comma. And then we print the new line, right? Because of println. But then what happens? Is that it? Well, that's actually not it. So we have to go back and evaluate all of these cases. Because remember, when we were evaluating these, all of these, we never actually finished the function, right? We only went to the function call. But once that function call is done, we have to go back to the function and then evaluate whatever happens next. That's just the nature of how functions work, right? That's how all functions work in Java. After you finish calling them, you have to go back and finish whatever was happening. So for t of 50, we call t of 55. T of 55 is just going to run whatever this print statement runs as. And it stopped right here, so we're going to go down here for t of 50. So remember that where a is equal to 50, and then we're going to say print 50. So we print 50, like that. And then we have to go back to t of 45, because t of 45 was being called, but then we called t of 50 with this function. So we have to go back and say, hey, I need to call t of 45. So let's go back here, and then we have to print 45, like this. And then similarly, we have to print 40. And then at that point, we started with t of 40, right? So t of 40 is going to do all of this, and then it's going to print 40, and then we're done. So yeah, that might be kind of weird, but that's actually how functions work fundamentally. So that's something to remember. So it depends not only on like what you're printing. Are you printing the result of this function? Are you printing some variables? But it depends on where you're printing. If you print at the beginning like this, then it's going to be different than if you print at the end like this. So let's see what happens when you print at the beginning with the same function, right? So in this case, we have already seen how all of the output stacks go. We saw 240, 45. Wait, I don't know why I wrote 45 here twice, actually. They should just go directly to 50. So, yeah, you can ignore this part. Let me just draw over that. Yeah, you can ignore this part. This will just go directly to here. 40, 45, 50, 55. But let's see what happens now when we're printing at the beginning. So, at the beginning, it's going to be, it's going to be A and then a comma. So same thing as before. Let's actually clear my output. I don't know if this is going to work. Let's just try, green. Okay, that works. Alright, so let me switch my color. So our output before, it was, we saw how it was going from 55 and then going back up the stack, right? So 55, 50, 45, 40. But now we're gonna start from 40. So we print 40 with a comma. And then on our next call, when we call try that with 45, we're gonna print 45 then, because that's at the beginning. So 45 comma, and then you can see we go to 50 comma, and then we call 55 right here, and then that's gonna print 55. So there's that for when the print statement is at the beginning. So it's very similar, right? Very similar to our previous one, except the numbers are in the reverse order. So yeah, that just goes to show how important it is to know what exactly you're printing in your case. And I put the answer here as well, so let's just check. So we saw like 40, 45, 50, 55 when we're printing at the beginning, right? And with our previous one, it was 55. This should say, I guess I wrote 55 here twice. That should be 40. So yeah, that's the answer for this one. So yeah, it depends on where you're printing. Let's clear this actually, because we have one more example, I think. Yeah. Let me just do it like this. Alright, our next example, let's see how it works. So we have do something. This is our next function. You can see here we have 3 base cases. So you can have multiple base cases, as I said before. And our recursive case is a multiplication, and then we increment value by 4. So let's see what we're doing. We're calling do something with 7. So let's say d of 7. So it's going to go here, value is 7. So what does this modulo percent operator do? It's called a modulo operator. But you can say mod for short. So val mod 4. That's going to be like, what is the remainder of dividing 4 into value? Well, it's going to be 3, because 7 divided by 4, that's going to be 1 in Java, but you're going to have a remainder of 3. So you can say return. Oh wait, no, I'm not doing this correctly. Sorry. So 7 mod 4, that's 3, right? That's not equal to 0. So this is not gonna run. Is 7 mod 3? 7 mod 3 is gonna be 1, right? Because 3 can go into 7 2 times. You got 3 and then 6, and then you have a remainder of 1. So that's not gonna be true because that's not 0. And then is 7 mod 2 equal to 0? No, because 7 is not even. So it's like, it's saying, does each of these numbers divide evenly into 7, or into value? But no, it does not for 7, so we call this. So we call 7 times do something of 11. So we say 7 times d of 11. So this entire thing is going to be the value of d of 7, because we're returning this entire thing, right? You see that this has parentheses around it. So we're returning the entire thing for the value of, for our call of d of 7. So d of 11 is our next call. When we say value is 11, none of these divide evenly, so we call 11 times d of 15 now. So this is our next call, and this entire thing is the value of d of 11, right? So d of 15, well, 4 is not divisible into 15. 3 is, because 3 times 5 equals 15. So we're going to have a value of 2 that's going to be returned to the function. So I'm going to draw an arrow to d of 15, and that's going to have a value of 2. So d of 15 has a value of 2. So now let's see what we get for d of 7. Well, 11 times 2, that is 22. And then 7 times 22, that is going to be 154. So because 7 times 20 is 140, and 7 times 2 is 14, so 140 plus 14 is 154. So you can see this entire thing has a value of 154, and that's what's going to be returned to d of 7. So if you see here, when we print the value of do something of 7, we're going to get 154. So this is the case where we only have one value that's being printed. Alright, so now we have our type along. This might be a little complicated, but we'll see how it goes. So let's say we want to write something that solves exponential problems. Exponentials are when you have something like this. So 2 to the 4th, that's how you say an exponential. 2 to the power of 4, you could also say. It's going to be 2 times 2 times 2 times 2. So you multiply it 2 4 times. So create a general algorithm for exponents by creating a method that calls, or that's called power, and it returns an integer. So your method name is going to be power. The method has two parameters, base and exponent, so the calculation is done as base to the exponent, like we saw here, or multiplying the base the exponent number of times. The base case should be where exponent equals 0, because anything to the 0th power is 1. Implement the recursive case. So I already give you like half of the method, so just write the recursive case for this program. So try this on your own. I'll give you guys, let's say, like 4 minutes, and then I'll come back and we can review it. So 4 minutes, try this on your own, and I'll come back. Alright, so 4 minutes has passed. Let me share my code window, so let's go over this. Wait, let me know how this program was on a scale of 1 to 10 in the chat also, because I don't know if it was like too complicated based on what we discovered or what we covered. Yeah, might have been kind of a little bit more difficult. But for recursion problems, it's kind of interesting because like you have to like think about them. It's not something that you can just like quickly like write down. Alright, anyways, let's make our 8th I think, yeah, 8th folder, and then I guess you can just call it like exponential solver. So that's gonna be our class name, right? Public class. Alright. And we're gonna have our main method as well, because we're gonna try running this. Let me put the prompt on there. Alright, what we're interested in is this next part. So it says we have two parameters, base and exponent, and then our base case is just this. Alright, so we can call it well, it says to call it power, so let's do that. So public int power, because it returns an integer. So this method has two parameters, so let's put those, base and exponent. Int base, int exponent. And it's giving us an error because we have to return an integer, but we'll do that. So we need to think about well, let's write the base case actually. So base case is when if exponent equals 0, then we just return 1, right? That's our base case. Otherwise, sorry, just making sure the recording is running. Alright. Otherwise, we have to see what we have to do. So when we are evaluating exponents, right, it's going to be base to the base times base and exponent number of times, right? So we're going to say base times something, right? And then we have to somehow find a way to evaluate the number of times that we're going to be running this, and we need to return there as well, because we're going to be returning this value to the function. So what could go here? Well, let's see. When we do 2 times 2 4 times, our base is 2 and our exponent is 4. So on our first call, it's going to be 2 times and then a call to this method again. And then we have to check, is exponent 0? Well, this checking of seeing whether it's 0, this is like saying how many times we have run this method, right? If we need to run it 4 times, then this is going to be 4, because we're multiplying 2 4 times. If we need to run it 3 times, it's going to be 3. If we need to run it 0 times, it's going to be 0. And then that's our base case. And then we check, we just return 1. So it can be a call to the function, right? And VS Code automatically gives us these parameters, base and exponent. But if we do that, if we do this without changing any of these variables, it's going to be an infinite loop, remember? Because exponent is never going to get to 0. It's always going to stay at whatever value this is, whatever value we called it with. So we need to think about this. Do we want to change base? Well, base is going to be the same for all calculations, so I don't think we should change that. Well, then we need to change exponent. But how do we change exponent? Well, for each call, if we represent exponent as like the number of calls, number of times this method is called, with 0 calls being the base case, then we can just say exponent should be decreased, right? But how much should we decrease it by? Well, for each call, that's going to be one number that we're multiplying, right? So we're going to say exponent, that's why we say exponent minus 1. Because we run the same function, but on our second call, and the subsequent calls after, it's going to decrease by 1. So that's going to tell us, hey, we ran this method 1 time, now check whether we ran it enough times. Otherwise, if we haven't run it enough times, call it again. So yeah, that's how you code the power function. It's only 4 lines. That's kind of like why recursion is so like elegant, because we're able to write this kind of like complicated thing but only using 4 lines. So let's test this. So let's say we want to print power 4. I mean 2 to the 4th. And let's make it static because it's not going to let us call it in the static method otherwise. So 2 to the 4th, well, 2 times 2 is 4, times 2 is 8, times 2 is 16. So this should print 16. Let's try running it. That's not going to let us run. Let's go to the terminal and then try running it. Terminal. Alright, so let's go to our 8th folder, and then let's type exponential solver, and then exponential solver. So yeah, it prints 16 because it's only printing this one number because that is the result of this calculation. That's what we're printing. So let's go back to our slides because we have one more type along. So yeah, these are the slides. Let's go on. So for this type along, this one might be a little harder actually. So let's just try what it says. In math, there's a sequence called the Fibonacci sequence. This starts out with two numbers 0 and 1. Then each next number is the sum of the previous two numbers. For example, 0, 1, and then we add 0 and 1, we get 1. 1 and 1, we get 2. 1 plus 2, we get 3. 2 plus 3, we get 5. 3 plus 5, we get 8. 5 plus 8, we get 13. And then so on and so forth. So create a method to find the nth Fibonacci number where n starts from 1. So the first number is going to be 0, right? Second number is going to be 1. Third number is going to be 1. Fourth number is going to be 2. And so on. So it gives us a hint also. So use two base cases. If n equals 1, then return 0. And if n equals 2, then return 1. So we already have two base cases. And then all we need to do is implement the recursive case like last time. So this is another example of how we can have multiple base cases. Let's actually try this. Let me go to the code window. So since we don't have that much time, I'll explain this one with you guys. So we have exponential solver, right? Let me share my window because I forgot to do that. We have exponential solver here. Now we need to make a new file. Let's just call it Fibonacci sequence.java. And this is actually like pretty famous in math. So you may see this if you haven't taken like algebra or geometry or any of those yet. So let's say we have a main method. Let me get the prompt as well. Otherwise I may forget to do that. So this is our prompt. Let me just format it. So we need to write two base cases first. So let's call our method public. Seems like we need to return something, right? We're returning the nth Fibonacci number. So we can say public int because we're going to return an integer, and then Fibonacci. Let's just call it that. It takes one parameter, right? We need to find a index. Except this index is going to start from 1. It's like the counting numbers. So our base case, if n equals 1, then we return 0. Otherwise, if n equals 2, then we return 1. Right, because those are our first two numbers. But why do we need two base cases? Well, because we're going to see how it actually works. Why we actually need two base cases once we write the recursive method. So we need an else case. So we're gonna return something. What do we return? Well, we need the sum of the previous two numbers. Now, considering we've already handled the case where n equals 1 and n equals 2, we need to handle all the other cases where n is some number greater than 2. So it's going to be 3, 4, 5. And at that point, we need to find the n minus 1 number, and we need to find the n minus 2 number. And then we need to add those, and then we need to return whatever that sum is, right? So because we've already handled the two base cases, all we need to do is handle the case where it's not any of these two. So let's say we want to return the sum, or let's just say first we want to return the previous number. So that's just going to be Fibonacci n minus 1, right? Because we've already written, or we're writing this method, we're finding a way to find the previous Fibonacci number using this. But then we need to find the one that comes before it as well, right? Because we need to add the previous two numbers. So we're gonna say plus, and then the one before this is just gonna be n minus 2. So Fibonacci n minus 2. And that's actually gonna be all of it. That's gonna be the entire recursive method. So let's just try running this. Let's make it static int, and then let's print Fibonacci 1, 2, 3, 4, 5, 6, 7, 8. Let's print the 8th number. Let's go to the terminal actually and run it. And it gives us 13 because that's it's running correctly. So let me know if you have any questions about this. I'll upload the code in the folder, and then I'll also send the recording. Let's go back to the slides and see if there's anything else. So yeah, there's nothing else. We've covered all the content for this class. Good work today, guys. I'll see you guys next time. I haven't decided on what exactly the next class topic is going to be on. So let me know if you have any suggestions. But other than that, you're free to go. So thanks for joining this class, and see y'all next time.